So what we have to learn today is how to go from standard form to vertex form, and the process that we're going to use is called completing the square. Completing the square is actually just one part of it, but we'll see it as we go. So here we have a function in standard form, y equals 3x squared plus 18x plus 20. Just looking at that, we know that it opens up. We know it's pretty narrow because of that 3 in front of the x squared. We know that it has a y-intercept of 20, but we don't really know much else about it. If we switch it into vertex form, then we will know where the vertex is. We already know the y-intercept, so we could get a pretty good idea of what the graph looks like if we switch it into the other form. So on the right there, you can see the instructions for doing it. The first step says to factor, but it's specific what we're going to factor. Because if you look at that 3x squared plus 18x plus 20 and you're looking for a common factor, there isn't one, other than 1. But what it actually asks us to do is factor out the coefficient of the first term. No matter what it is, no matter whether it's a common factor or not, we're factoring out the coefficient of the first term from the first two terms. So we're just looking at this, and a lot of times that coefficient of the first term will be a common factor, but not always. We're going to factor it out anyway. So for this one, we're taking the 3, which is not the greatest common factor because 3x would be, but we're taking the 3 out of those two terms, and it's going to look like this. Y equals 3, and then open a bracket, x squared plus 18x. Sorry, that's not 18 anymore, is it? What should it be? 6x. And then I'm going to leave a big space and then say plus 20. And I'm leaving the space so that I can do the second step. So divide the 3x squared by 3, you get x squared. Divide the 18x by 3 and you get 6x. That's the first step. So you don't have to think about what's the greatest common factor. You just factor out that coefficient no matter what it is. The second step says complete the square to make a perfect square trinomial by adding a 0 pair. So complete the square to make a perfect square trinomial. That's like finding the value of c that we were doing earlier. What value can we add to x squared plus 6x to make it a perfect square trinomial? That number is 9. Now, x squared plus 6x plus 9, that's a perfect square trinomial. Remember how you do that. To find that number, you take the middle term, which in this case is 6, divide it by 2, and square it. And that gives you the 9. That's where that number came from. But see how it says add a 0 pair? Do you know what a 0 pair is? It's two numbers that when you put them together, they make 0. So if we added a 9, what other number can we add to make a 0? Negative 9. So we're going to do plus 9 and minus 9. The reason is we want to change the way this expression looks, but we don't want to change the value of it. So by adding 0, we don't change the value. We just change what it looks like. We want that 9 there to make a perfect square trinomial, but we have to subtract 9 as well to make the value of it stay the same. Now the third step, remove the extra term from the brackets. Which one's the extra term? That minus 9, that one that we added just to make it a 0 pair. So now it's going to look like this. Y equals 3, x squared plus 6x plus 9. And then we want to take that negative 9 out. When we take it out, it needs to multiply by the coefficient in the front. So it doesn't come out as a negative 9, it comes out as a negative 27. And the plus 20 is still there. Fourth and final step, factor the trinomial and simplify. We've been practicing factoring, but there's a shortcut to factoring this. Because it's a perfect square trinomial, and we know that it's a perfect square trinomial because we made it that way, we can go like this. take the square root of the first term, so that's x. Take the sign from the second term, so it's positive, and then take the square root of the last term and square it. Because when you factor that, you get x plus 3 times x plus 3. But it's just kind of a shortcut, takes you to here. And you can always do that if you know it's a perfect square trinomial, which you will in these because you made it a perfect square trinomial. So square root of the first term, sine from the second term, square root of the last term, that's the shortcut, and then square it. And then I just need to simplify. So negative 27 plus 20 is negative 7. And there's the function in vertex form. How could we check and see if it's correct? Put the original one you were given and the one that you found in your calculator and see if they graph the same. That's a quick, easy way to check. You could also, you could expand that back to standard form and see if you get the same thing, but it's probably going to be quicker just to check on your calculator. This question is worded differently. It's not saying take this function and change it into vertex form. It's saying algebraically determine the coordinates of the vertex of that function. The way that I would do that is by putting it in vertex form. So that's what we're going to do. There is another way to algebraically find the coordinates, and we did that the other day, but we're not going to do that. We're going to put it into vertex form. So the first step was factor out the coefficient of the first term from the first two terms. So the coefficient is negative 2. We'll factor it out. We get x squared. And what does that second term turn into when we factor out negative 2? Minus 5x. And remember, leave a big space so that you can complete the square. Now the second step is to find that number that you can add on that will make it a perfect square trinomial. So we take half of 5. We're going to keep it in a fraction, yep. We'll take 5 and divide it by 2 and square it. So 5 squared is 25. 2 squared is 4, so it's plus 25 over 4. But I need to make that 0 pair because we don't want to change the value. You can't just randomly add 25 over 4 to an equation. It makes it a completely different equation. So if we add 25 over 4, we want to subtract 25 over 4 because now it's still the same equation. All we really did was add 0, which doesn't change anything. So remember where that fraction came from. Take 5, divide it by 2, and square it, which just means square the top number, square the bottom number. 5 squared over 2 squared is 25 over 4. Now we'll take out that extra term. There's the perfect square trinomial, x squared minus 5x plus 25 over 4. We'll take out the negative 25 over 4. When we do that, what do we multiply it by? Negative 2. That's a step that people forget a lot. But make sure when you take this last number out, you multiply it by the number in front. So this will be plus 25 over 2 and plus 7. It won't be minus because it's negative multiplied by negative. So it's plus 25 over 2. That's 25 over 4 multiplied by 2. All right, we're almost done. Last step, factor the perfect square trinomial. So square root of the first term, that's x. Sine from the second, so it's negative. And then the square root of 25 over 4. Square root of 25 is 5. Square root of 4 is 2. Square it. And then I want to add 25 over 2 plus 7. And that's going to be 39 over 2. And there's the equation in vertex form. The question asked, what are the coordinates of the vertex? So what are the coordinates of the vertex? 5 over 2 and 39 over 2. It's not negative 5 over 2 because remember you take the opposite sign for the p-value.